Hi everyone, I'm back again. I assume really putting all these together so one day I can go become a YouTuber, you know, sell these for lots of money, make loads of money from my advertising and go on Strictly Come Dancing. But until then, I suppose I've got to build up my library. Today we're going to be looking at the working memory model. Which is our second model of memory that you need to know, second and last model of memory that you need to know, as outlined by Baddeley. He does a lot, doesn't he, in this topic? Baddeley and Hitch, initially in 1988. As you'll see, though, as we go through, Baddeley and other psychologists do add to this as they are going. Just one thing to clarify. Obviously, the multi-store model, we know the multi-store model is sensory memory that feeds into short-term memory, that feeds into long-term memory, and also retrieval allows you to bring long-term memory back into short-term memory. You'll notice an arrow is missing at the moment. We need rehearsal there to keep information in our short-term memory. So the multi-store model attempts to clarify or model all of memory. However, the working memory model is only focusing on what's happening here in short-term memory. So everything I'm going to draw today only focuses on the short-term memory. Remember, one of the criticisms of the multi-store model is that it's too simplistic, that there's more to short-term memory than just holding information and repeating it over and over. The working memory model attempts to solve that criticism by making a clearer or more detailed picture of the short-term memory. So we're going to start with the first system in the working memory model. That's known as the central executive. The central executive is called the master system in the model. It's called the master system because it's the big boss. It's the one that's in charge of everything else. It is responsible for controlling attention, and therefore control of attention, remember, is that process that allows us to get information from our sensory memory into our short-term memory. So information comes from the sensory memory to the central executive, and the central executive decides whether or not we're going to pay attention to it. If it decides we are going to pay attention to it, then it moves from sensory memory into short-term memory. We can start consciously processing it. It is also involved in decision making. So deciding on how we're going to use information, looking at information coming in, deciding what we're going to do with that information. And it gives information, it allocates information to the slave systems. We'll look at the three slave systems in just a moment. The difference, remember, the central executive is the master system, not a slave system. Really importantly, the central executive has a very limited capacity. It can't hold very much itself, but that capacity is modality free. You remember that term means that it can use any type of encoding. It can hold any type of information, visual, auditory, any type, as it comes from the sensory memory, will stay in the central executive. Now, as a master system, the central executive can control various other systems in working memory. The first one we're going to look at is known as the phonological loop. Hopefully you've guessed by the name, the phonological loop is all to do with sounds. It's all to do with how things sound and holds your acoustic information. So the coding is acoustic there in the phonological loop. Essentially, if any information comes into the central executive, that's sound-based. The central executive is going to want to send it to the phonological loop because that's the system, the slave system, that deals with sound-based information. So just remember our first slave system. The phonological loop is made up of two parts. The articulatory control process, and also the phonological store. Now these parts do different things. The articulatory control process is like your inner voice. It repeats things to yourself. That, when you're thinking to yourself in your head and you hear the words in your head, in your mind, that's the articulatory control process working. Remember, we have to repeat information, we have to rehearse information to keep it in a short-term memory. If it's verbal information, the articulatory control process is what's doing that rehearsing. The phonological store is like your inner ear. It's there just to hold the information, to look after that information. And the information will last for about 30 seconds. Remember Peterson and Peterson. And if it's longer than 30 seconds without the articulatory control process rehearsing it, then it will be lost from the short-term memory. So the articulatory control process there for rehearsal of this verbal information. So that's our first slave system, the phonological loop. The second slave system we need to know about is the visuospatial sketchpad. You might see it sometimes called the visuospatial scratchpad. Now, the visuospatial sketchpad, again, you probably can guess, uses visual coding. So if information is coming into the central executive that is based on pictures or images, the central executive is going to send it to the visuospatial sketchpad to be processed. Again, we've got a slave system just here. The capacity of a visuospatial sketchpad is 3 to 4 items. So 3 to 4 different images. You can test that, for example. Here's a little task. What I want you to do is imagine the letter J and the capital letter D. And I want you to move those around in your mind to produce an umbrella shape. It's quite easy, isn't it? The D simply fits on top of the letter J. Now what I want you to do, so that's just 2 items, you hold that in your visuospatial sketchpad quite easily, and you can move those around in your mind quite easily to do that. Now what I want you to do is another task. I want you to hold in your head so visualize the letter D, the letter J, a question mark, the letter P, the letter D, 2 squares, and a triangle. And now I want you to put those all together to make a house. It's a lot harder to do that, I think you'll find, because we've got much more than 4 items there, and the visuospatial sketchpad, which you're using to put those things together, gets a little bit overloaded. Again, Logie, I said there was going to be some additions to Baddeley and Hitch's original model. Logie in 1995 breaks the visuospatial sketchpad down into a visual cache, which is our storage, like our inner eye, and also an inner scribe, which Logie says is responsible for processing the arrangement of objects. So the inner scribe is telling me, even though I can't see it, that I've written the multi-store model up here because that's being held in my short-term memory. I can use my inner scribe to know that my wife and Freddie are out in the garden without me looking at them because it's holding that arrangement over there. The visual cache, the storage, is what I'm actually using there when I was doing that task with the J and the D. It's that inner visualization. So we've got our second slave system there, the visual spatial sketchpad. The final slave system that you need to know about wasn't added by Baddeley until much later in 2000. It's called the episodic buffer. Baddeley added this because before this, there wasn't really anywhere for the short-term memory to store anything that wasn't phonological or visual spatial. And we know that the short-term memory can store more than these two types of information. We also know that between these three things, there doesn't seem to be that 7 ± 2 capacity. So the episodic buffer was added essentially as a third slave system, which is a general store. So the episodic buffer is a general store of information. It's again modality free. It can store and code any type of information. And we think it's got a capacity of, again, about 4 chunks of information. So between the episodic buffer, the phonological loop, the visual spatial sketchpad, we do have now that 7 ± 2 items. The other important bit about the episodic buffer is that it has access to the long-term memory. So if I need to do any thinking about anything that's going to require my long-term memory, the central executive is going to send the episodic buffer to dash off to my long-term memory, which Baddeley and Hitch see like a giant filing cabinet. The episodic buffer looks through that filing cabinet, finds the information from the long-term memory, brings it back to the central executive, which the central executive can then send to the phonological loop or the visual spatial sketchpad, depending on how I'm going to be wanting to talk about it. So there you have the bare bones of the working memory model as described by Baddeley and Hitch, our AA1 for it. Let's do a few tasks just quickly to go through and demonstrate how these things actually work. The first thing I'd like to do is imagine your house. Okay, from the outside, I assume you're inside your house at the moment, staying safe. But from the outside, imagine your house. What I want you to do is have a walk around your house and count up how many windows you've got. Okay, just in your head, there's no need to get up outside and go and do this. Just imagine walking around to the outside of your house and counting the number of windows. What you'll be doing there is using your visual spatial sketchpad. You're imagining a picture of your house in your head that's being stored in your visual cache, and you're having a walk around that in your mind, visualizing it, counting the number of windows using your visual spatial sketchpad. The other thing that's going to be interesting that you're using here is the episodic buffer. Obviously, you're not outside your house at the moment. So what your central executive's decided that you've got to use is your long-term memories of what your house looks like from the outside. So the central executive is sending the episodic buffer to go and get the long-term memories of your house from the outside. The episodic buffer is bringing those long-term memories back to the central executive, who's sending it to the visual spatial sketchpad, who's actually doing the counting of the windows. Let's have a look at a different task then. Here's another task. I want you to pick a song and sing it. What's happening here? How's your working memory doing this? Obviously we've got sound now because it's a song. We're using our phonological loop. How it's happening, the information's coming in from my voice into your system through your sensory memory. Hopefully your central executive is telling you to pay attention to it. It's being passed to the phonological loop, and that's decoding the instructions from my voice. Once the phonological loop now realizes that it needs something from your long-term memory, some lyrics to a song, it's sending that information back to the central executive, which is then going to tell the episodic buffer to dash off to the long-term memory to get the lyrics to your favorite song. Once those lyrics are back, the episodic buffer sends those to central executive, who again realizes that it's acoustic information, which was sent to the phonological loop to be processed, so that you can actually then sing those lyrics to that song. If, on the other hand, I wanted you to picture someone, your favorite singer, singing that song because you're picturing it rather than hearing the sounds, that would be using your Visual Spatial Sketchpad. I hope you found that useful. I hope you found that interesting. Obviously, this is just AO1. There are various bits of AO3 we can add to this. Some of my favourite evaluation points here, positive ones that you've already looked at, the case study of KF. You could also use dual task studies from Baddeley. In support, and because these are lab experiments in controlled conditions, you've got all the research methods criticism you can add to this to double burger it. And one other thing you'll come across is the idea that the central executive is very vague and very difficult to test, perhaps a little bit unscientific in what Baddeley and Hitch explain about what it's actually for and what it actually does. If something's hard to test, it's hard to falsify, that makes it a little bit unscientific because we can't prove that it's right or wrong, and therefore that's a criticism of the model because we can't test it. Okay, hope you found that useful, hope you've enjoyed it. Build your evaluation, make sure obviously you've got 5 evaluation points on this. Make sure you've got, you know your AO1, make sure you know this diagram, make sure you can talk about the working memory model, and I'll leave it there for today.